Hey class, so I'm just going to do a real quick video and kind of go through and explain how to use histograms and central tendencies at the same time. So first thing, number one, visual representations of data, for me, I think are a really easy way to kind of look at and see what's going on, and often you can see and kind of guess like what's happening with the central tendencies based on kind of what you're seeing in the histogram. In this example, and this should look similar to one of the problems that you have, we've got 4 different arrangements of histograms, and this problem wants to know like order the means. Which one of these has the greatest mean to the least mean? And if we wanted to, we could look at each one of these data sets and we could say, okay, so for example, if I'm looking at A, I could say, all right, well, so this data set has two 2s, 2 5s, an 8, 3 10s, and 11, right? So I can just tell that by just looking across the data. And then if I wanted to, I could get my calculator out and I could calculate, excuse me, I could calculate exactly what the mean is there. And I could do all of my calculations and find the median and the mode and all those things. And but what we want to be able to do is to kind of look at these and make an estimation instead of having to do the calculation every time. So one of the easiest ways to do that is to just make comparisons. So I'm going to say, okay, look, here's A and here's C. Well, how are they the same and how are they different? So if I look across these, right, this is the same, that's the same, that's the same, this is the same, and now here's the difference, right? So A has 2 5s, and C has one 5, and then 1 3. So if you look at its lineup of data, right, the mean for C is going to be less than the mean for A, because this 3 is smaller than the 5, and so that's going to pull the mean, comparatively speaking, to a lower number. Okay, so that's that one. Let's make another comparison. Let's compare A to B and see what we have. So comparing A to B, so this is the same. Okay, then I can see our difference, and then these two things are the same. And so B has 4 10s, and A has 3 10s and an 8. So the mean for B is going to be greater than the mean for A, right? B is going to have a bigger average than A because it has larger numbers. So then I can come here and I can add that to this. So the mean for B has to be bigger than A, and if it's bigger than A, well then it's also then must be bigger than C. Okay. So then, okay, now we need to find out where D fits into the picture. And for D, what I'm going to do is I'm going to compare it with B here, just because they're on top of each other. It's a little bit easier. Okay, that's the same, that's the same. This is the same. Okay, and now here's my difference. B has 2 2s, but D has 1 2 and a 4. Okay, so that means that the mean for D, right, since it has a larger number, is going to be greater than the mean for B. And so now I have my list. I have a way to kind of quickly look at and organize, okay, so the averages, C is going to have the smallest average of the group, then A, then B, then D is going to have the largest average out of the whole group. And you can make these comparisons just by quickly kind of looking back and forth between the histograms. Now we could have just listed out all the numbers and calculated everything and then figured out that way, but that would have taken a little bit longer. And this method, as long as your histogram stacks are reasonably small, you can make a pretty good approximation. So this is one way of kind of looking at histograms and making judgments about what the average is or what the mean is. Okay. The next one we want to look at is this graph here. And in this one, so it's asking us to estimate. It says, okay, estimate the mean, the median, and the mode, okay, from this set of data. So the easiest one to estimate is going to be the mode, right? I'm going to look, and you just find, right, the mode is the number in a set of values that occurs the most often. So when I look across this, well, I say, okay, well, something in between 50 and 60, right? This is the tallest. So there's some value in there. The mode is most likely hiding within this range. Most likely. This one's a little bit harder to tell because, for example, if the number between 30 and 34 is, let's say it's 33, there may be 4 33s in here, and we just can't see it. But the range, at least we can say the range that occurs the most often is the range between 50 and 60. And that's about all we can say without knowing individual data points for the mode, okay? So that's the mode. Not super useful. The median, on the other hand, this one's a little bit easier to pinpoint because it's the number in the middle of the data set. And so, we can look and say, okay, well, how many numbers are there in here? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so there's 20 values, right? 20 values. So normally you would take that and divide by 2. To find out where the middle is, and the middle is somewhere around 10. Now the problem with distributions that have even numbers of things is, so for example, I could count back 10. So if I come over here and start counting back 10, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means that whatever the lowest value is in the 50 to 60, and whatever the highest value is in the 40 to 50, I would have to take those two values. Let's pretend that they're 47 and 52, and the number in the middle of those would be the median. And so I would add those together and divide by 2. But I can't see that. So a histogram like this that has ranges, it's a little bit harder to do these adjustments because I can't see the exact values, but I know that the median is somewhere between 40 and 60. That's a large range. And it should be really close to 50, okay? Because 50 is kind of that boundary, right? Technically, my counter landed me on the boundary there. But so then the last one that we can kind of think about here is the mean. And with this one, we can actually get a decent estimate for what the mean is. Okay, so the way that this works is normally, if you were calculating a mean, you'd have, you'd have like 1, 3, 5, 7, right? You'd have all these numbers, and you would take them and add them up, right? So 7 and 3 is 10, plus 5 is 15, plus 1 is 16, so you'd have 16, and you divide that by 4. To get the average, and so the average would be 4, right? Hooray! Because there's 4. Anyways, so I mean that's normally what you'd do, but in this case I can't see the individual numbers, and so what I'm going to do is I'm going to say, okay, well, let's take an average, or let's grab the middle of each of these things. So right, there's 25. And there's 35. And so in between 20 and 30, I know there are 2 values. So I have 2 values that are probably close to 25. Plus, okay, now I have 4 values that are probably close to 35. Okay? And again, and this is why we're just estimating, right? Each one of these is an estimation. Okay? Plus, okay, and then I have 4 values again close to 45, and again, I'm just picking the middle of each of these ranges, plus 5 values that are close to 55, plus 3 values that are close to 65 plus 1 value that is close to 75 plus 1 value that is close to 95. Okay, so I'm going to take 2 times 25 plus 4 times 35 plus 4 times 35 plus 5 times 55 plus 3 times 65 plus 1 times 75 plus 1 times 95, right? I'm going to do all of that, and when you add that all up, you end up with 1,010, okay? And then the last step in an average would be to divide by the total. We already know that the total is 20, and so that gives me an average of about 50.5 when you do that, right? So again, I'm approximating the average using this trick of saying, okay, I'm going to pick the middle of the range, and then I'm going to count how many things are in that range, and this is going to be my summation. And so this is where I'm estimating on, and then I divide by the total number of things, which I can see by counting that. So anyways, so when you're dealing with mean, median, and mode and histograms, this is one method of kind of getting an estimate of where those values are within each of the things. And the estimator that I'm the least accurate with is the mode, because since I can't see what the individual values are, like I don't know, these may be all individual numbers, but these may all be the same number. So it's really hard for me to tell where the mode actually is, but I can say that the range that has the biggest number of counts is 50 to 56, but that's not really what the mode is. So the mode is not as helpful of a thing to try and estimate with a counter like this, but that's how that works. So when you're dealing with histograms, there are ways of just getting relatively quick estimates for what those central tendencies are. Let me know if you have any questions, and have a great week. Thanks. Bye.